Algebra of functions. In this section, we're going to combine old functions to create new functions. That's what we're going to do. So our goal is basically to combine old functions to create new functions. So let's get started. So we're going to combine old functions to create new functions. Okay, so here's the first way we can combine functions. It's just by simply adding them. Okay, so a good way to represent that is, first let me go ahead and say, if we're given, let f of x and g of x be two functions with domains. I'll call the domain d of f and d of g. So we have two functions, f of x and g of x, whose domains are that. Okay, so I'm going to create new functions out of those two old functions. So I'm going to start with this. My first function is going to be f plus g of x. So this is my new function. All I'm doing is taking this function and adding this function. So I'm going to get f of x plus g of x. This is just a compact way of writing that. Okay, if there was a minus in the middle, then this would be a minus here. So I could get two new functions by subtracting them. Another way I can get a new function is by actually multiplying them. I can take f times g of x. Okay, that's a new function, which is basically the function f of x multiplied by g of x. And I can do the similar thing with division. I have f divided by g of x. That's a new function, which is the old function f of x divided by the old function g of x. Okay, now it's obvious out here g of x cannot be 0, because if it is, then we're going to get division by 0. So this is how we create new functions. These functions on the left are my new functions, which are created on the right using the old functions. Okay, before we go any further, the domain of the new functions, the domains of the new functions is the values of x where the domain of the old functions overlap. Okay, alright, except in the case of number 3 here, we also have to worry about this condition. Okay, so I'll just put that note. In case of 3, I'll just call that 3, we also want the domain of f divided by g of x not to include values of x for which g of x is 0. Okay, so that's a special case just for that one, and I'll explain this when we do an example. So let's take a look at an example. Okay, so let's say if we have this, we have f of x is equal to, okay, let's start with something simple and then we'll work our way to a different problem. X squared plus 2x, and g of x is equal to x minus 2. Now what's a domain of f here? The domain is basically all values of x for which the function is defined, and the only time we have to worry about is if we are dividing by 0 or if we are taking square roots of even roots of negative numbers. Now, for division by 0 to occur, x would have to be in the denominator. It isn't. And to end up taking square roots or even roots of negative number, x would have to be inside an even radical, which we don't have. So the domain out here is all real numbers. Same logic tells us that the domain out here is also all real numbers. That means everything from minus infinite to infinite. Alright, so now let's calculate this. Let's say if they come and ask us to find f plus, let's do minus, f minus g of x. You take the function f of x and you subtract the function g of x. So let's do that. What is f of x? It's x squared plus 2x. Make sure you guys put parentheses because there's two terms. Minus x minus 2. If you don't put parentheses, you're going to lose a negative sign. We're just adding polynomials, so you just distribute. So we get x squared plus 2x minus x plus 2. So we get x squared plus x plus 2. So there's my new function, f minus g of x. And what's the domain of this function? You don't go by what the domain of this is, you go by the domains of these. What did we say? The domain of the new function is wherever the domains of the old functions overlap. Where they overlap. In this case, since the domain of this is minus infinite to infinite, this is minus infinite to infinite, the domain of this will be minus infinite to infinite because they overlap everywhere. Okay. Now let me give you another problem. Out here they specifically asked us to find f minus g of x, the function. Okay, but what if they'd asked us this, f plus g of 2? They do not want us to find the function, they just want us to find the value of this function, this new function at 2. If the input was 2, what is the value of f plus g? What is the output? Well, I know what this function looks like. This function is what? The old function f of x plus g of x. So in this case, since they're not looking for the function, I can just take f of 2 and add g of 2. I don't have to actually find the function. Out here we actually found the new function. Out here they just want us to find the value of the new function at 2. So we take the value of the old function at 2 plus the value of the old function at 2 there. What is f of 2? In this old function, replace x with 2. I'll put parentheses, so I get 2 squared plus 2 times 2. In the g function, replace x with 2, so I get 2 minus 2. So we get 4 plus 4 plus 0. So we end up with 8. So if they don't ask for the function, don't waste time trying to find the function. Just find the value of that function at whatever x they give us. 2, 3, minus 1, whatever. Okay. Let's do one more example. Let's say they want us to find f of g of x. In this case, they want us to find the function g of f times g of x, a product. So you take f of x and you multiply it by g of x. So what was f of x? It was x squared plus x, again put parentheses since it's got two terms, and this was x minus 2. All we're doing is multiplying polynomials, so we distribute. So we get x cubed minus 2x squared. We distribute the x. So we get plus x squared minus 2x. So we get x cubed minus x squared minus 2x. So there's my new function, fg of x. Okay. Now let's just say for the sake, and the domain of this would be what then? Since the domain of this and this overlap everywhere, the domain would be the same, minus infinite to infinite. Let's say now they had asked us to find f of g of minus 1. Okay. They didn't ask us to find the function. Over here, because they put an x here, they wanted us to find the function, the new function f times g. Out here, they just want us to find the value of the new function at minus 1. So you take the value of the old function at minus 1 multiplied by the value of the second old function at minus 1. So what is f of minus 1? And the old function f, replace x with minus 1. So you get negative 1 squared plus minus 1. I'm going to put parentheses because my input is negative. And then you multiply that by g of minus 1. So we get minus 1 minus 2. So in the function g I replace x with minus 1, and the function f I replace x with minus 1. So let's clean this up. Negative 1 squared is 1, minus 1 times minus 1 minus 2. So we get 0 times negative 3, which is just going to be 0. So out here, had they given us this problem, then all we had to do was just find the value at minus 1. We didn't have to find the new function. Let's check it though, since we have the new function f times g. Let's see what happens if we replace x with minus 1. Do we get the same answer? So let's do that. What is fg of minus 1? In this function, replace x with minus 1. So you get negative 1 cubed minus minus 1 squared plus 2 times minus 1. Let me write it better. We have fg of minus 1. We get minus 1 cubed minus minus 1 squared minus 2 times minus 1. Minus 1 cubed is minus 1. Minus 1 squared is 1. And then negative 1 times negative 2 is positive 2. So we get 0. So we see we got the same answer. But this way, if we had done it this way, we first would have to find the actual new function and then find the value of the new function at minus 1. But if they don't ask us for the new function, just do it this. It's much faster. Okay. The last example of this is this. Let's say they want us to find f divided by g of x. So you take f of x divided by g of x. So I want to find the new function f divided by g. F of x was x squared plus 2x, and g of x was x minus 2. So there's my new function. Okay. Now, what's the domain of this? Well, the domain of all the other functions was wherever they overlapped. In this case, that is also true. Let me just show you here by a number line. This is infinite minus infinite. So the domain of f and the domain of g are where they overlap everywhere. Correct? But now, because g was in the denominator, we want to exclude all values of x for which this will be 0. This will be 0 when x is negative. When x is 2, I'm sorry. So you come over here. When x is 2, you take that number out because x cannot be 2. If x is 2, I'm going to get division by 0. So now my domain is everything that's left. It's all of this and all of this. So my domain is minus infinite to 2, not including 2. So we put parentheses when we don't want to include the endpoint. And then we put or we can use the union symbol to combine, which means 2 to infinite. This union basically means or. The domain is this or this. Okay. Alright, so that's how we calculate the domains and the overlaps. Let me just do one last example. Let's say if I have f of x is equal to square root of x plus 2 and g of x is equal to square root of 3 minus x. Okay. So let's find the domain of this. Now the domain, like I said, you always start off assuming it's all real numbers. Okay. And then you start excluding things that cause problems, x values that cause problems. The first x value you exclude is anything that causes division by 0. There's no x in the denominator, so we don't need to worry about that. The second x value we get rid of is those x values that make square root, that end up with square root of negative numbers. So we want to find out when this will be negative. So let's solve for that. We want to solve when x plus 2 will be less than 0. Less than 0 means negative, correct? So let's solve this. We get x is less than negative 2. Okay, let's make this a 1 just for ease. I might have to change that further, but so x is, I'll make this a negative also, less than negative 1. Okay, I'll make this a positive, a negative. I'm just trying to come up with a good problem, so we move the 1 over so it becomes a positive 1. So I want to exclude all the numbers that are less than 1. So these are all of these numbers. I want to get rid of all of them. So what's left is my domain. So my domain for this function is 1 to positive infinite, everything that's left, including 1. Okay, so let's do the same thing for this. I might have to change it a little bit. I want to get the right problem. Assume everything works. X is not in the denominator, so we don't need to worry about division by 0. Then we want to solve what? We want to find out when negative 3 minus x is going to be less than 0. Because if I can find that out, I can exclude all of those numbers. Okay, so in this case, if you move the x over, you get negative 3 is less than x, so x is greater than negative 3. So you want to exclude all the numbers that are greater than negative 3. Okay, actually let's go back and make this a plus, so that'll be better. All the numbers that are greater than 1. So here is 3. So I'm going to exclude all the numbers that are greater than 1. So I'm sorry, 3. So I'm going to exclude all of these. Okay, so what's left is my domain. So what's the domain of G? It's everything from minus infinite to 3, including 3. So these are the good x values, and you can check them. If I pick 0, if x is 0, you get 3 minus 0 is square root of 3. That's a good number. On the other hand, if I pick 5, if x was 5, that's not in the domain. You get 3 minus 5 is square root of minus 2. We cannot take square root of negative numbers, so that's bad. Similarly, you could have checked your answers over here too. Alright, so we got our domains. Now let's find a couple functions really quick. Let's just do two examples, 3 examples. Let's do one. Let's say I want to find f plus g of x. I want to find this new function f plus g. What does that mean? You take f of x and you tack on g of x. What is f of x? F of x is x minus 1, and you add g of x, which is 3x minus x. And there's your new function. There's not much you can do with these two. Okay, so that's what we end up with. What's the domain of this function? The domain of this function is where would these two domains overlap, where they intersect. Okay, so let me just show you. The domain of this function is from 1, I'll use a different color. So this is the domain from 1 to infinite. So I'll use, this is the domain of f. And then the domain of g is this. It's everything from 3 to minus infinite. So where do they overlap? They overlap right here in the middle. Okay, so the domain of this function is going to be 1 to 3. Okay, those are the only values that are going to work wherever they overlap. Alright, let's say that they come and ask us to find f times g of 2. Now, they didn't ask us to find the function out here. They wanted us to find the function. They just want you to find f times g of 2. So they want you to find f of 2 multiplied by g of 2. So what is f of 2? In the function f, this is right here. Replace x with 2. So we get square root of 2 minus 1. Multiply that by, in the function g, replace x with 2. So we get 3 minus 2. So we get square root of 1 times square root of 1, which is just 1, because square root of 1 is 1, 1 times 1 is 1. So that's all we had to do. They wanted us to find the value of this new function at 2, not the function itself, just the value. That's faster to do. The last example I want to do is, if they want you to find f divided by g of x, they want you to find this new function. So you take f of x and divide it by g of x. So what is f of x? Well, f of x is square root of x minus 1, and g of x is square root of 3 minus x. There you go, there's your answer. Okay. Now technically you shouldn't have radicals in the denominator, so you should really take care of that. You can rationalize this. You can multiply the top and the bottom by the same square root. Okay, so in this case, on the bottom we just get 3 minus x, and on the top we can multiply this out on the inside. Okay, we get x times this is 3x minus x squared. Then you get minus 3 plus x. and then we can clean that up a little bit. So we get minus x squared plus 4x minus 3 divided by this. Okay, so there would be a new function f divided by g of x. Now what's the domain of this function? The domain of this function will still be the domain wherever these two overlap, these two domains overlap, which is this pink region. But we also want to exclude what? Anything that causes division by 0. So when will this be 0? When x is what? 3. So the domain of this function will be the pink domain, which we found in the first case to be this, but x cannot be 3, so we cannot include a square bracket here. We have to use a parentheses, because if x is 3, I'm going to get division by 0. So the domain of this would be 1 comma 3, not including 3. Okay, so that's how we create new functions from old. There's another way to create new functions from old using something called composites. Composite functions. Basically, a composite function is a function made up of another function. Normally a function is made up of a variable x. You have it's f of x or f divided by g of x and so on. But what if instead of x you had another function here, h of x or something? That's what a composite function is. So let's take a look at a notation of the composite function. This is a notation for composite function. We write f naught, this thing stands for composite, of g of x. This basically translates to that f of g of x. Okay, so that's what it translates to. Okay, so if you have two old functions f and g, I can take their composites and create a new function f of g of x, where f is made up of g of x. Okay, not of x but of g of x. Similarly, if you reverse the order, we get g naught of f of x. That would be g of f of x, where g is made up of f of x. Okay, remember this is not multiplication like we had earlier, f times g of x. That's different. This is composites. Okay, so let me give you an example just to show you that. Let's go back to the previous example that we had. We had f of x is x squared minus x, and g of x was x minus 2. So you guys can see how different this is from multiplication. So let's say I want to find f naught of g of x. I want to find this new function, f naught of g of x. So let's do that. Okay, to find f naught of g of x, what do we do? Okay, the first thing we do is rewrite this in the regular function notation. You take f of g of x. Now, if I had f of 3, what would you have done? In the function f, you replace x with 3 because this is my input, right? And my input is usually x here in this case. So I'm replacing all the x's with 3. So in this function I would replace with, I get 3 squared minus 3, so I get 9 minus 3. I'll end up with 6. Okay, that's what I do. I'm going to do the same thing, except now in the function f here, I'm going to replace all the x's here with the function g, which happens to be what? X minus 2. So I'm going to replace, I get f of, this g is x minus 2. So I'm going to replace now all the x's with x minus 2 in the function. So what is f? X squared minus x. So instead of that, it'll be x minus 2 squared minus x minus 2. So do you see what I'm doing? I'm replacing this x with the function g, which is x minus 2. So this x gets replaced with that because my input now is x minus 2. I'm replacing this x with the function g, which is x minus 2. So my input is x minus 2. Now this is a binomial squared. We know how to do that, right? We had a formula for that. If you've forgotten, you can take x minus 2 squared. My base, you're going to multiply twice, x minus 2 times x minus 2, and you can FOIL. Okay, and do that. So, or you can use the formula that I showed you. You square the first, then you multiply the first and the second, so you get x times 2 is 2x, and you multiply that by negative 2 because there's a negative in the middle. So you get negative 4x, and then you square the second, we get 4. Out here we distribute the negative, so we get negative x plus 2. So we end up with x squared minus 5x plus 6. So there is your composite function f naught of g of x. Okay. Let me go ahead and show you something else while we're at it. Let's say if they had asked us to find f naught of g of 3. Out here they asked us for the function, so we found the function. But out here they didn't ask us for the function, they just want us to find the value of the composite function at 3. So you just do f of g of 3. Since f is on the outside, it stays on the outside here. So you find g of 3 first. In the function g, you replace x with 3. So you get 3 minus 2, which gives us 1. So I get 1. G of 3 is 1. I'll just write it on the side. Since g of 3 is 1, we get 1. And what is f of 1? In the function f, you replace x with 1. So you get 1 squared plus 2 times 1. So you get 1 plus 2, which is 3. It just so happened that they both ended up being, the input and the output ended up being the same, but that's not always the case. Okay. Alright, so if they don't ask us for the function, don't go through the extra work like we went through to find the function. Just find the value of the function at whatever point they gave us. Now, they could also have asked us to find g naught of f of x. What does that mean? You find the function, evaluate the function g at f of x. Okay? Because g is on the outside, it stays on the outside. So what does that mean? G of x squared plus 2x, because that's what f of x is. So in the function g, I want to replace all the x's. Remember, my function g is this. I'll just write it on the side. I want to replace all the x's with x squared plus 2x, because this is my input now. This is what I want to evaluate the function g at. Normally we evaluate it at 3 or something like that. We replace x with 3, so we get 1. But instead of 3, we have something more complicated, x squared plus 2x. But that's not a big deal. Just follow the same rule. Replace the x in the function g, this x, with this input. So we get x squared plus 2x. I replace this x with that, got that, minus, I still have the 2. And there's your function g naught of f. Now, just like before, if they just wanted us to find this g naught of f of minus 4, okay, we don't have to find the function. Out here they asked us for the function. Out here they want us the value of the function at negative 4. So you just take g of f of minus 4. Okay, so you come on the side and do that. What is f of minus 4? F of minus 4 means you replace in the function f, replace x with minus 4, so you get negative 4 squared plus 2 times negative 4. Remember to put parentheses. Negative 4 squared is 16 minus 8, so you get 8. So we end up with g of 8. What is g of 8? In the function g, replace x with 8. Here's my function g, x minus 2, so we get 8 minus 2, so we get 6. So there's the value of this new function at negative 4. And we can test it over here because we already have that new function, don't we? If you wanted to test it, if you could find this and then evaluate that at negative 4. So let's do that on the side. X is negative 4, so we get negative 4 squared plus 2 times negative 4 minus 2. So we end up with negative 4 squared is 16 minus 8 minus 2. So we get 16 minus 10, which is 6, which is what we had. But to do it this way, we would have to first find the function. But if they just want us the value, you can do that. And that's how you create new functions from old functions. And you could also have complicated functions. I just used 2 very simple functions, but that's not always the case. Okay, so just keep that in mind. Let me give you one last example. Let's say if you had f of x was 3x minus 2 and g of x was x plus 2 over 3. Let's find f naught of g of x. We want to find this. Okay, what does this mean? You take the function f and evaluate that at g of x. So what does that mean? In the function f, you replace everything with g of x, which happens to be this x plus 2 over 3. So that's fairly complicated, but that's okay. Just follow the same rules in the function f here. This is f. Replace all the x's with this little chunk, whatever that happens to be. Don't worry about how complicated it looks or how goofy it looks. Okay, so this x here gets replaced with this. So we get 3 times x plus 2 over 3. I'm putting brackets since I have multiple things here. Minus 2. Since this is multiplication here, I can cancel these. So I get x plus 2 minus 2. The 2's cancel, so I get x. Okay, so that's kind of neat that we were able to do that. In this case, what does that tell me? Whatever input you provide, your output is going to be the same. So basically, if I find f naught of g of minus 5, the answer is going to be minus 5 according to this. Or f naught of g of 10, the answer is going to be 10. Because, again, you can see f naught of g of x is just x here. So it doesn't matter what x you give, the output is going to be exactly the same here. Okay, so that's kind of neat about this particular example. Okay, so those are new functions from old functions.